Okay, so today in math, we are going to work on a problem string. And then after our problem string, you're going to do a quick multiplication checkpoint. And then whatever time is left, you will be working on Dreambox. So in your yellow math notebooks on the next blank page, I want you to title your problem string partial product and then the date, which is November 10th, 2025. So anytime you hear the word product, you are going to know that you are going to need to multiply. So our entire problem string is going to be about multiplying. Remember that when we start our problem string, the problems are going to be relatively easy, and then as we go, the difficulty will build. But many times you can use the problems you've already done to help you solve the new problems. So as I give you this problem string, I'm going to give you the multiplication expression, and then I will say, I want you to pause your video. When I say pause your video, that's your cue to go ahead and solve your problem. I'm going to keep going. So when you're ready, you will just unpause and then you'll hear the next part of the problem string, okay? So the first one I would like you to solve on your own is 3 times 23. So go ahead and pause your video and solve in whatever way makes sense to you 3 times 23. Some of you might do 23 plus 23 plus 23. That would get you to the right answer. Some of you might be comfortable doing the standard algorithm when it comes to some of these 2-digit by 1-digit numbers. So you might know that 3 times 3 is 9, and then 3 times 2 is 6. So either way, your answer would be 69. The next problem I want you to do is 30 times 23. So go ahead and pause your video, and I want you to solve 30 times 23. Some of you might have figured out, oh, wait a second, if I know that 3 times 23 is going to give me 69, I know that 3 times 23 times 10 is going to give me 690. Now, in this case, you would not want to just add 23 30 different times. That would take you forever. You might think to yourself that you could draw an area model for this. So it might look something like this. And you know that you could split up 30 into, let's say, 20 and 10, and then we can split up 23 into 20 and 3. This might make it a little bit easier for you if you know that 20 times 20 will give you 400, and then 20 times 3 will give you 60, and 20 times 10 will give you 200, and then 10 times 3 will give you 30. If you add all of those up, you're going to end up getting your answer. So if we do 400 plus 200 plus 60 plus 30, then we will get 690. The next one I would like you to do is 33 times 23. So what can you use based on the knowledge that you've already solved? How can you use that knowledge to help you solve 33 times 23? Go ahead and pause your video and go ahead and try to solve 33 times 23. Some of you might have just realized, wait a second, I already know 30 times 23, and I know 3 times 23, and 30 plus 3 is 33. So if I add those two numbers together, I will get the answer. So if you add the answer to 3 times 23, which was 69, and 30 times 23, which was 690, and you add those together, you will get 759. That is one strategy you might have used. Another thing that you could have done is you could have done another area model. So this time, if we break it up into 20 and 3, and instead of 20 and 10, which would give us 30 like the last problem, you might have split it into 30 and 3. So in that case, you would do 20 times 30, which is 600, 30 times 3, which is 90, 20 times 3, which is 60, and then 3 times 3, which is 9. And if you add all of those together, you would get 759. You could also do a ratio table. Your ratio table might be kind of long, but you could get to it using a ratio table, and some of you might have tried to do that. So that would work as well. The next problem I want you to do is 60 times 23. So before you start, I want you to think about what number have we already worked with that we could easily manipulate or easily do something to get to 60. So we already know 3 times 23, 30 times 23, and 33 times 23. So how can we get 60 times 23? Go ahead and pause your video and tell me or show me how you would solve 60 times 23. Some of you might have thought to yourself, well, I already know 30 times 23. So if you know that 30 times 23 equals 690, if you double 30, what do you get? You get 60. So 60 times 23, this number, this 690 then, must also double. So if you think 690 plus 690, now you would be able to easily say, well, I know that 60 times 23 is 1,380. Just remember that if you double one of your products, then your answer will also double. That is going to be probably your easiest way to solve this problem. Of course, you could do an area model with this as well. So some people might have done like I did, showed you up at the top. You might have broken up your area model into, you could do 50 and 10, which would give you 60, and then 20 and 3. 50 times 20, 10 times 20, 50 times 3, and 10 times 3. So that is another way that you could solve this problem. Definitely what you don't want to do is you don't want to add 23 60 times. That would take you forever, and you don't want that. Okay, so a couple more. Next one that I want you to try is going to be 66 times 23. Just as a little hint, what number have we already done that would help us solve this problem? Go ahead and pause your videos. Try and solve 66 times 23. If you were really listening to what I said the last time when I told you that if you double one of the products, then your answer will double, then you might have thought to yourself, well, wait a second, I already know that 33 times 23 got me 759. And if I double 33, I get 66. And if I double one of my products, that means that my answer is also going to double. So doubling 759 is a lot easier than having to write the number 66 23 different times. So if we double 759, we know that 9 plus 9 is 18. 5 plus 5 is 10. Regroup the 1. 7 and 7 is 14. So your answer would be, that is a 5. That looks kind of like a 6. Let me fix that. So your answer would be 1,518. So it is super helpful to use numbers that you already know about to help you solve some of these problems. Another strategy you could have used is our lovely area model. So I would just take 60 and 6, and then I would take 20 and 3, and then I would solve it from there. So 6, oh, my pen is not being very nice. 60 times 20, which would give me 1,200. 60 times 3, which would give me 90. 20 times 6, which would give me 120. And then 6 times 3, which I didn't have enough room, would give me 18. So if you added all of those together, you would get 1,518. Okay, so this is the last problem. Obviously, or like you've known before, that the last problem is always the most challenging. So the last problem that we're going to do, I'm going to make this a lot smaller, is I want you to solve 43 times 23. What could you do here? 43 times 23. We have not necessarily had a double of this number that we could use, but what information do we know, or how could we make it easier? One thing that I like to think about is just like we've done in our area model, is splitting those bigger numbers apart to help with this. So 43, oh, and I said 23, didn't I? That's okay. We're just going to stick with it. So 43 times 23, I'm really just going to break up that 43 into 40 times 23 and 3 times 23. And that might help me more easily get the answer. So if I'm doing it in an area model, that would look like 40 and 3 and 20 and 3. And so basically what you're doing is you are coming up with partial products, which is the title of this problem string, to help you solve this. That's what we did all the way up here when we did 30 times 23, and then 33 times 23, 60 times 23, 66. So all of those are basically giving us partial products. They're giving us parts of the multiplication equation that we can use to add up and then get the whole number. So when you're doing this, you're thinking, okay, so 40 times 20, you can do that because, well, 4 times 2 is going to be 8, right? So if 4 times 2 is 8, then 40 times 20 is going to be 800. We've talked before about how if you see 2 zeros in your product, then you are going to have 2 zeros in your answer, okay? So the next one would be 40 times 3, which you know that 4 times 3 is 12. So 40 times 3 then would be 120. The next partial product would be 20 times 3. So 2 times 3 is 6. So 20 times 3 would be 60. And then our last one, this guy always gets forgotten about, but he is going to be 3 times 3, and then we know that 3 times 3 is 9. Now, if we add all of those up like we did previously, we would get 800 plus 120 plus 60 plus 9. So your answer then would be 989. So the last thing that I want to do is I want you in your notebook underneath your problem string, I want you to write these words. So I want you to write partial product And then I want you to write the definition as a strategy for solving multiplication problems. Partial products are going to be super, super helpful when we start solving these larger multiplication problems. So with that, I am going to go ahead and say goodbye. You're going to take a quick checkpoint on multiplication, and then you will be doing Dreambox for the rest of your math time. So I hope that you were able to follow along and come up with some good strategies. I cannot wait to see your problem string and what you've done, and I hope you have a great rest of your day, and I will see you tomorrow.